The internet. We use it every day for everything from gaming to news to cat videos. Aw. But despite the ease of access from just about anywhere these days, it's not a magic information field. So, where does it come from? After all, there isn't one big room that just hands out bandwidth. Instead, the internet is a network of networks. It links together all of the individual servers, computers, and devices across the planet. More and more of our communications and all of our websites live there and travel across it. For most home users, internet access starts at an internet service provider, or ISP. Some ISPs buy their own service from even larger ISPs, and at the top of the stack are the Tier 1 providers. These huge networks connect to one another with the help of underwater data cables. They're what make the internet global. Not everything travels across those cables every day, though. Companies like Netflix and Google run their own data centers, which connect to the rest of the network at boring buildings called Internet Exchange Points. If you're checking your email or streaming video, chances are it's coming through one of these exchange points and then through your ISP to you. All told, it's a lot of traffic. The International Telecommunications Union estimates there were some 3.2 billion people online in 2015, sending more than 20,000 gigabytes per second, and traffic is expected to triple by 2020. That's a lot of cat videos. For Newsy, I'm Cliff Judy.
Okay, great. Hi guys, I'm Julian, and I'm welcoming you to this computer networks class. So the very first video was just to give you an introduction of what we are meant to learn throughout this semester online, and what you expected to know. It's like the gentleman said, ISP, which is an internet service provider, and how data flows from one side to the other. So here we will be basically looking at the bolts and nuts around the network, about around the computer network. And then we will use this book. Basically, the sixth of or the seventh version of this book will be alright, but then I'll be going with the slides of the eighth version. So this is basically our roadmap, or I would say the introduction, what you feel about that. The first thing we would have to see is basically what is internet, and as you know, the internet is a network of network, a protocol, how computers speak to each other, the different components of a computer, basically the different components of a network. You have the network edge, network core, and then you have the performance for the network, you have the security in the network, and then you have the different layers you have, because there are multiple layers in a computer network. Yes, so as you know, as most of you know, internet is just a network of networks, right? And what is a network? A network is just a a set of two things that can speak to each other. So you and your friend, you're already a network. And when you go and meet another friend, then you create even a bigger network. That's the reason why in some companies they speak about networking events. So you try to know the maximum of persons you can. In the technological world, then we have devices, right? We have here you have a car here that, like those Tesla cars, you have maybe a network robot or traffic light, you have your cell phone, you have your laptop. All of those things are called hosts. So those are the pieces of the network that make the network active. Now you have the devices that make basically make the data leave from one place to another ones. Like we call them, we have different devices. One of them is the router, the one you know very well. You have it at home to have internet. And then you have the switches. You might not be very close to switches, but then those are devices that make move data from one computer in a network to another computer in the same network, right? A very big example is the device that is in the computer lab. They have it, and you will see all the cables are basically converging towards that particular box. That's probably a switch. And then you have your communication link. That's basically the mean with which you're connecting to the network. So here I didn't speak about the router. If you connect to internet probably with the fiber, then you have that little box there that will provide a wireless signal, and then you will connect to that particular router to have internet. Or if you also at school you have this type of cable that we call the RJ45 or the Ethernet cable that will also provide you access to internet. All right. Now, at the end of the day, you have your full network. Your full network is basically a set of like we said, a network of other networks, and each network can be different from each other, right? You have a network of switches. You have a network of servers, data centers. You have an enterprise network like the VITS network, for instance, right? VITS provides internet for all of us within VITS. And then you have the regional internet service provider. Then you have the other guys. So this is what we call a full network, and then it's a subset of the internet. So today we have so many connected devices, and these ones are very diverse. Like you see, we have now glasses that are connected to internet. We have smart watches, phones, pacemakers, fridge even that can basically order milk if the milk is missing. Like, okay, there's no milk, and then can go to the Google Assistant or Apple Siri and make an order because the fridge said there is no milk in the fridge. Okay, so ISP, Internet Service Provider. It's basically a company that provides internet to you. So it's the company that sells the internet to you, like that access to the other rest of the network. But then how does it happen, right? How do we actually speak to that particular website you try to get, like Google? How can you help me to do my homework? Like, you need to speak to Google, and what we use what we call a protocol. So a protocol, it's a way of speaking to a page. It's like, remember when you come and sit on your desktop, then your desktop, it's a person, and you want to speak to another person. And when you want to speak to a person, from the very first thing you need to do in the morning is to say hi, and then the conversation goes on. The network, you have some network standards here that basically enforce everything about the internet, and the most important one you need to know, these are the two ones, and especially the latter one that tells you how the rules on internet go, right? Like that www, why we have the .com, what's the shape and form of a website. So these type of things are ruled by that IETF, the Internet Engineering Task Force. Yeah, you can go and have a look at it. And here on this picture, you have the different protocols and applications that we have in our network. And these will be part of the following lectures. You have one protocol here called the TCP, right? This it's a very interesting protocol that we'll use in a communication, right? We want to make sure that the data is coming and going in order. We have Skype, as we know, is that application that that allows you to speak to some other people, and you have multiple other applications that will help you to do the communication between devices. Talking about the infrastructure, So it's basically like I said in the previous slide, but then you would see that you would want to have something like a device that would bring your data, your big amount of data from one place to the other. And the applications are like you have multiple of them. You have your Netflix, which is part of streaming. You have your YouTube, or which is also streaming to listen to your music, your Spotify, your Gmail, your WhatsApp. Everything needs to speak to a network. And most of those are basically similar to a postal service where you have to make sure that you understand where the email is going to, where it's coming from, where it needs to go, where it needs to pass by. So that you need to understand. Okay, so here, what is a protocol? So I spoke about that slightly earlier. A protocol is just a way of discussing, or like a way of making a conversation between two entities in a network and in the real world, right? So like if I want to know something, I need to ask you a question. If I want to come and speak to you, I might come and say hi first, and then you'll tell me hi back. It means that you understood what I meant. And then the conversation can happen. In a computer network, it's the exact same thing, right? A computer needs to send a request to the computer, to the remote computer. Can I have the information from you? And it's like, yes, you can. This is the response. And then you say, I would like to have a file. Then there is your file. And end of transmission, end of transmission. In the human communication, we can shake hands and say bye. Okay, here you have a normal discussion or an analogy between a human conversation or a human protocol and a computer protocol. And as you can see, the lady is saying hi, the guy is saying hi back, what's the time? And the time is 2. And then you see that the conversation is ordered with time. You can't come to tell someone that it's 2 p.m. when the person didn't even ask you a single question. That is not normal. Same happens to a computer network. Hey, I'd like to have the file. This is the file back. So it will be now up to you to know what are the other human protocols. Like there are any other human protocols that basically help us to communicate between each other, and then it will help you to understand how a network or how computers in a network work. Okay, so this from now on we'll be speaking about the different pieces in the network, in a computer network. And a little note here: the video might end up being long, and you can pause anytime you want. You can rewind the video. You can take notes. Feel free to do so. Do not rush through the end. Understand whatever is going on. It's not a sprint, right? Just go very slow with us. All right, so here we have the whole computer network as we saw earlier, right? But let's see what we call edge. So an edge is basically a single part, like a receiving end of the signal in the network. When you're on your phone using WhatsApp, sending a message to your friend, then you are basically an edge, right? Some sort of application hosting WhatsApp, then that's one thing. And your server that's also receiving your request to send it to the other one is just also one part of the edge of the network. It's like in mathematics, you have this idea of vertices, and each vertex, it's basically, yeah, I mean, an edge, it's the connection between two vertices. But then in this case, take the network edge as a vertex in the network. All right, so now you have the communication between them, right? And to connect all of these things, as you can see here, we have these edges that connect two network edges or two endpoints, right? It can be wired. You can have your wire cable or your internet cable as you call, but then we call it technically the RJ45. Or you can have your router, like which is the wireless communication between two devices in a network. As you know, at WITS, for example, you have multiple wireless devices that will help you to connect to the internet. And then we have the network cores. Those are the big guys. Those are the big setups that would help you to actually make move. Like let's say when you are in WITS Stadium and then you would like to have access to the WITS library, then these network cores will help you to send your request to the library. I would like to read this book, and then we'll send you the book going through all the other all the different hops of the network. Right. Basically, um, the way you connect to a network, or the way you connect, the way you basically request something from a network, it's not straightforward. Although internet started becoming very, very fast with multiple technologies like the 4G, recently the 5G, the optic fiber and stuff like that. But then there are multiple places where your request will come and take a rest and go to the next one before going to the data center, right? But then you need to know some few things here. You have different types of networks. The most important ones are these three. I mean, it's not an exhaustive list, but then it will help you to understand what's going on. Residential access network. This is actually what's happening by your house, right? So there's an internet service provider that would basically say, okay, cool, we'll distribute internet to you, to all of you, from our network service, like from our network devices. So they will basically hand you a router or maybe another device, and then you will connect to it and you will have internet. You have institutional access network. For example, the one you will find in a bank, like FNB. When you go to FNB, you can connect to their own internet network where they'll say, okay, we give you internet for free. This is through FNB institutional network access. The mobile access network, that's what we all have, right? You can connect to the Wi-Fi through your phone, but then you can connect to 4G, 5G, Edge, any of those technologies with your phone, right? And you will have internet. Okay. So those are the different part of the network you need to understand. And mostly when you deal with these technologies, you need also to understand the transmission rate. That's how you can tell how fast your internet is. Like if you go to that page on Google with I guess it's test my speed, then you can tell how fast your internet is, right? Cool. Now we have different mediums of accessing the internet, and this is the very old. This is one of the oldest medium of internet we used to have. It's like you have a cable that's basically connects. That's basically from a source, right, to basically multiple other people. That runs on a cable based internet transmission, and you have that cable head end, sorry for that, that basically receives all the instructions coming from each and every computer of the network, and then it goes on this side, and after that we have the signal split into channels and sent back to the users. That's pretty old, and we barely use this type of technology to have internet today, right? So yeah, um, here if you have to extend only that the previous one we were speaking about to the newer uh, technologies we have. If we're speaking about a cable-based technology, then you have your internet service provider at the other end of the head end side of the network. It provides internet that everyone is using, like literally in that sequence, right? So you have your speed that is not that great. But the most important part, home share access network cable, like it's a shared access physical cable to everyone else. Like this is not very ideal, and it's not very secured. But then it works for TV transmissions and stuff, and in the past for internet. You have now the DSL, like the digital subscriber line, and I'm sure some people might not know that, but then it was a very fast internet uh, medium where you could have the phone and then you can have the internet, and then you have that splitter that does the division between your voice coming from the phone and your data for the internet, right? It splits everything here. Everything just happens here, and then you have your DSL, and you were having a very decent internet connection. Obviously, it was very wired, and in the back end of the other side of the digital subscriber line here, you have your internet service provider. So some people might use it, some people might use it, but then it's very old, and basically people do not actually use fixed phone anymore unless it's used in an office or stuff like that, right? Okay. Right. Now we're coming towards what you guys know. These are the two components that, let's say the three components that you are very, very used to. Your internet provider, right, comes with a box in your home. It's like, okay, guys, we brought you the fiber, and you have to connect your Wi-Fi router through that, and then you'll be having internet through the whole house. This is basically how it works nowadays. Here you have your router. Here you have your switch. Usually they all together here, and then you have your that little device that brings the internet at home. And these two are basically there to translate the signal, the internet signal, into whatever the device can understand. Okay, cool. So all of these, what we just mentioned, are part of your internet connection here. So I just mentioned all of that prior everything else, but then now you know what's going on. Cool. Okay, so here we have the wireless access network. Today, we can use every medium or a lot of medium to have internet uh, to our devices. So the phone, computers, our cars, our connected watches. So those things are possible with the what we call towers, like internet towers, and they will help us to relay the data from one side to the other side and another side, or we have cables somewhere that basically broadcast some sort of internet data, and we receive the internet data as we subscribe to it. As when you buy airtime, you turn it into data. That's basically how you subscribe to most of those mobile data or mobile networks. All right. The enterprise network, it's similar to what we use at VETS, right? So you have multiple ways of connecting to the internet. As you know, some of you guys might not have a Wi-Fi in their computers. Then they'll say, can I have an internet cable? to plug on my laptop. Yeah, sure. Then you plug the internet cable that we call the Ethernet connection, and that's a pretty fast connection as it doesn't have any noise. You see, it doesn't travel through air to get to your device. But then you have now the Wi-Fi, which is the signal that goes through air. This is the undirected mean of having your internet connection. Then the speed is slightly slower than the Ethernet, but then it's also very reliable. Today it can send a lot of data at a very reliable rate. All right. So you cannot speak about networking without speaking about packets, about data. Everybody is speaking about data. What is data? That is just an entity that we're making travel in the network. The data doesn't go as it is. Sometimes you can have 2 to 3 gigs of data, even 500 megabytes of data can be too big. Then the data is broken into chunks. Each chunk is called a packet, and a packet it's having a length, right? It has a size. Now we calculate the rate at which data leaves from one side to the other side with the transmission rate, and we calculate it with the formula below here. In your mathematics classes, you would see that if we have a quantity which is the number of bits, right, in bits, and then we have our transmission rate in bits per second. When you divide all that, it gives you a quantity in second. That will give you the time of transmission of one side of the network to the other side of the network. That's basically how you can say that the network is pretty fast. So this is what I was explaining from one side to the network on basically the switch here, and then from the switch to your computer or to your phone if you're using some sort of WhatsApp or something like that. All right, physical media. Physical media are your internet cable. Your We'll speak about some of the physical medium here that will help you to have internet. So the bits they basically sent in those components, right? They they can fit in here when they leave the first part of the network to the second part of the network. They are part of guided media. So guided media because you can actually see a hardware that will hold your data and will leave from one side to the other. Unfortunately, you can take some scissors and then cut that. For sure, the data will not go on. And guided media, then you have the radio part, which is your Wi-Fi, which is your mobile data, which is your cellular towers data, all of those type of things that will help you to have internet without having a single cable. You have your twisted pair, and then sorry, it's not me, but it's been called the RJ45. This is the common internet cable that you would see. There's another cable that looks like this called the RJ11. That's for telephones, and we don't use that anymore. You can go and Google that, and you have to make the difference. The RJ45 has a thicker cable, and the RJ11 has a small one. Some other physical medium, then we have the coaxial cable. This cable, it's an old cable we used to use. Usually they present in the TV setup when you wanted to plug your dish straight to your TV. Then you use this one, and there's a little component in front of it that would help you to secure that particular cable to the back of your TV. So it can go up to 100 megs per channel. And 100 megs today, yes, it's affordable, it's nice, but yeah, it can do the minimum what you need. And then we have the one and only, the optic fiber or the fiber optic cable. This one can, it's like, this is very new. We all know about the optic fiber. And you see, compared to what the RJ45 and the coaxial cable, this one has a speed or a transmission rate that can range from 10 to 100 gigs of of um, of 200 gigabyte per second, right? This is very fast because optic fiber has some sort of glass in its composition that makes it pretty frictionless in terms of data retention. It makes it then very fast to leave from one point to the other one. Now you have your wireless radio. Your wireless radio is like, as we can see here, no physical wire, right? Propagation through the environment. It suffers from reflection, obstruction, all of those type of things. Then we're speaking about your wireless signal. So if you are in your home, you might suffer of a lot of things. The signal is blocked by a wall. The signal, there's a lot of interferences between the signal and the microwave signal and the TV signal and many other signals. We will speak about the different channels that we use in propagating a signal in a network. I'm sure some of you heard about the 2.4 gigahertz and the 5 gigahertz frequency transmission. It's not the topic of this lecture, but then this is a very important section that you need to understand, and it will be nice for you if you can basically describe a network from what we spoke about. And the last bit here, it's like you have we spoke about the wireless LAN, which is the Wi-Fi. We spoke about the mobile data, which is your cellular data. You can activate your 4G in your whoever net mobile carrier you use. And then we have the satellite. This one is a very technical device to use, right? Because you have a satellite somewhere, and then you basically say, give me internet straight from the satellite, or give me the request straight from the satellite, and then you process that. Obviously, it's slightly expensive than your typical wireless Wi-Fi setting with your internet service provider that you would find on Earth. But then, if you really want faster things like having NASA type of information, then you can go for that. And I guess it's available for very big research units. So this is the end of our first lecture. There won't be any very hectic practicals, right? But then I'll produce a quiz for you guys so that you have a little sense of what's going on. I'll ask you some few questions on what you understood from the lecture and what you need to prepare for the next lecture through these quizzes. The next step, it will be for you to use Java to write some sort of little communication between two applications. And at the end of this semester, you should be able to write a client server application that speak into a network. Again, I'm welcoming you to this class, and hopefully I'll see you next time. Bye.